Black hole stars may have been the largest stars to ever exist. They burned brighter than galaxies and were larger than any star today or that could even exist in the future. But besides their scale, what makes them special and weird is that deep inside they were occupied by a cosmic parasite, an endlessly hungry black hole. How is that even possible? To know the possibilities behind this impossible question, keep going with the video. Watch it till the end. Hope you enjoy watching this video. Then please give it a thumbs up and do share it with other keen learners like you. Don't forget to hit the subscribe button and also click on the bell icon for further new notifications. Now, let's get started. Black hole stars take the weirdness of black holes and go beyond to break everything we know about how stars form and grow. They were only possible during a short window of time in the early universe, but if they existed, they would solve one of the largest mysteries of cosmology. Black hole stars were excessive any way you look at them. The most massive stars today may have about 300 solar masses. A black hole star had up to 10 million solar masses, nearly pure hydrogen. Let us take a moment to look at what this means visually. The Sun, Vision, LL Pegasi, the largest star, Stephen's Sun, and finally the black hole star. Its scale is beyond words. Over 800,000 times wider than our Sun, 380 times larger than the largest star we know today. And far below its surface is a black hole, growing rapidly as it devours billions upon billions of tons of matter per second. Normally, stars are born from gigantic clouds, collection of thousands to millions of solar masses, of mostly hydrogen. In these clouds, matter starts to accumulate around the densest spots inside. As these spots get denser, their gravitational pull intensifies and they grow faster. Eventually, they generate so much heat and pressure that they ignite fusion reactions and a new star is born. But this puts a limit on their size. Nuclear fusion releases enough radiation energy that the surrounding gas cloud is blown away. The new baby star can't gather more mass. From now on, the star is living on the edge between two forces, gravity pulling in, trying to squash the star, and radiation created by fusion pushing outwards, trying to blow the star apart. After millions to billions of years, the core runs out of fuel and the balance breaks, destroying the star. But black hole stars were very different. Very, very different. The beasts of the early universe. A few 100 million years after the Big Bang, when the universe was much smaller, all the matter in existence was much more concentrated. The universe was much denser and hotter. Dark matter was a dominant player, forming giant structures called dark matter halos. These dark matter halos were so massive that they pulled in and concentrated unthinkably gigantic amounts of hydrogen gas, becoming the birthplaces of the first stars and galaxies. Epic clouds of hydrogen formed, some as massive as 100 million suns, more than the mass of small galaxies. In this unique environment that will never exist again, the enormous gravitational pull of the dark matter halos grew gas into its center and created extremely massive stars. As we said before, when a star is born, it blows away the gas cloud that created it. But these titanic gas clouds in the early universe were so large and massive that even after their birth, more and more gas piled on the newborn star, making it grow to unbelievable proportions. The young star is forced to grow and grow and grow getting more and more massive, until in some cases it reaches up to 10 million times the mass of our Sun. Crushed by gravity, its core gets hotter and hotter, desperately pushing outward, trying to blow itself apart, but to no avail. There is too much mass and too much pressure. The balance is impossible to uphold. Like a supernova on fast forward, the core gets crushed into a black hole. Normally, that would be the end. Today's stars go supernova, a black hole forms, and things calm down. But in this case, the star survives its own death. A tremendous explosion rocks the star from the inside. But it is not enough. The star is so large and massive that not even a supernova can destroy it. But now, it has a black hole for a heart. It is tiny, a few tens of kilometers, in the center of a thing the size of the solar system. The monster grows. Stars are born from even faster spinning and collapsing gas, and so they also spin. When a black hole is born from the core of a star, it keeps its angular momentum. This means that matter that gets drawn in doesn't just fall in a straight line, but instead begins orbiting a black hole. In smaller and smaller circles, going faster and faster. The result is an accretion disk. When gas orbits at nearly the speed of light, only a small amount of gas actually falls in at any given moment. Basically, black holes put a lot of food on the table and only nibble at it. But the matter trapped in the accretion disk doesn't have a good time. Friction and collisions between particles heated up to temperatures of millions of degrees. Actively feeding black holes have accretion disks that are incredibly hot and powerful. The heat from the disk further restricts how much a black hole can devour. Just like the core of stars, the super hot material that creates radiation that blows away most of the food within its reach. So even if a black hole had access to as much food as it desired, it can only grow slowly. A black hole embedded inside a black hole star is different. The enormous pressure surrounding it pushes down matter directly into the black hole, overcoming all restrictions on how fast it can consume. This process is so violent and releases so much energy that the accretion disk becomes hotter and releases more radiation pressure than any star core ever could, enough to push back against the weight of 10 million suns. An impossibly dangerous balance has been created, millions of solar masses pushing in, the angry radiation of a force-fed black hole pushing out. For the next few million years, the black hole star is consumed from within. The black hole grows to thousands of solar masses, and the bigger it gets, the faster it eats, which heats up the star even more and causes it to expand. In its final phase, the black hole star has become over 30 times wider than our solar system, truly the largest star to ever exist in the universe. The intense magnetic fields at its core spew out jets of plasma from the black hole's poles, which pierce through the star and shoot out into space, turning it into a cosmic beacon. It must have been one of the most awe-inducing sights to ever exist in the universe. But this also marks the end. It becomes too stretched and the accretion disk within too powerful. Parasite destroys its host, blowing it apart. Black hole with the mass of 100,000 suns rips its way out to hunt for new prey, while leaving behind nothing but a star carcass. Supermassive question. If black hole stars existed, they could explain one of the greatest mysteries of the universe. The supermassive black holes we see at the center of galaxies are just too big. They should not be possible. Black holes born from regular supernovas can be a few tens of solar masses at most. Because of the process we explained before, they grow slowly after that. If black holes merge together, they can form slightly larger black holes of over 100 solar masses. It should take billions and billions of years to make black holes with hundreds of thousands or even millions of solar masses. And yet we know that some supermassive black holes already had 800 million solar masses only 690 million years after the Big Bang. Black hole stars are a sort of black hole cheat code. If they formed very early in our universe, and the black holes that emerged from them were thousands of solar masses, then they could be the seeds for supermassive black holes. These seeds could take root in the center of the earliest galaxies, merging with others and drawing in enough matter to grow quickly and reliably. Very soon, we may be able to verify their past existence. The James Webb Space Telescope is turning its sensors to explore the farthest reaches of the universe, looking back in time, back to the early universe that we could not see before. So, with luck, we might be able to witness the glimpses of these tragic titans in the brief moment between their formation and destruction. So that was all for today's video. We'll meet in the next video. Till then, take care of yourself and bye bye.